All right, so this is going through all the parts. Okay, the first thing that you want to do is identify your end behavior, looking for the highest exponent. I should have switched this up so you get used to it. Highest exponent this time was first, but not, you make sure it doesn't always have to be first, okay? So it's an even power, it's positive, which means it rises left and rises right. And then I found the zeros. So I set it equal to 0. I factored out the 2x squared and got x squared minus 25, difference 2 squares, factors, to x plus 5 and x minus 5. Now that 2x squared means it would be plus and minus 0, which is important because that means there's 2 zeros. So the multiplicity on that 0 is 2. Then negative 5 would have a multiplicity of 1, positive 5, 1. Your y-intercept is 0, 0. It doesn't help you this time because you already had it, but sometimes if you don't have 0, it's going to help you. So then I plotted the points. I drew my arrows up. And I knew it had to cross through, bounce off the middle, and then cross through. But I have to figure out how far down it goes in between those spots. And for this, having it symmetric to the y-axis made it easier. But then I literally just plugged in 2. I plugged in 2, and you got a really negative number, like negative 168 or something like that. And I don't need you to go to negative 168, but what I do want you to do is make sure you plot it and then label it so that I would know that that is supposed to be negative 168. And then because it's symmetric to the y-axis, it would reflect on the other side, which eliminates the need for me to plot another point. So it's still an approximation, obviously, how low it goes, but the rest of it needs to be exact. You need to be able to describe your end behavior by saying it rises left and rises right. Okay, you need to be able to find your zeros with your multiplicity and then use the graph to show what that does, whether it bounces or crosses through. You need to be able to find your y-intercept. The y-axis is not going to ask you for symmetry, but obviously that helps you eliminate some work.
How do you know what to plug in order to find how low it goes?
You just want to plug in something in between your 2 points. Because it's 0 to 5, I didn't want to plug in 1. 1's pretty short. It's really close to 0. I try to find something in the middle. But I'm certainly not going to plug in like 2.5. Like that would be a nightmare. So I just pick a whole number in between those two.
Would 3 have been?
Yeah, it's fine. 2, 3 are fine. 2 or 3 are fine. Questions on this? Okay. So your quiz covers up to that point. Tomorrow I'm going to leave you the full warm up for 2-2 and the quiz review, and you can work on it. It is 1, 6, 2, 1, which is all the quadratic stuff. 1, 6 was the inverse. 1, 2, 1 is all the quadratic stuff. And then 2, 2 up to this point is what's on your quiz. But on your test and moving forward, we're going to finish out 2, 2 because that is still part of the rest of it. All right, so polynomials of higher degree continued, okay? Now we are flipping the information. So in part 1, part of the information you found was your zeros. In part 2, you get the zeros and you have to find the equation. Yes. So in order to find a function, if you're given your roots or your zeros or your answers, you're going to write an equation that says f of x equals x minus the root. When you do x minus, if it starts as a positive root, then obviously it's going to be negative in my equation. But if it starts as a negative root, it's going to become positive in the equation. So let's just say I had negative 2 and positive 7. I would do x minus a negative 2 becomes plus 2, and x minus 7, and then you just FOIL it out. That's it. And then at the end, you're going to set it equal to f of x because it's a whole function. So look like this. Find the polynomial function that has the given zeros. So I'm going to do x plus 1, x minus 3, and x minus 4. And then it doesn't matter in which order I FOIL these out. I could pick any 2 to start with. I'm going to pick these 2. And all right, so then I'm going to distribute x times x is x squared, x times negative 3 is negative 3x, 1 times x, and negative 3. Combine your like terms. And from the first 2 parentheses, I get x squared minus 2x minus 3. And then I'm going to bring down the x minus 4. And I'm going to multiply it out. So the first term goes to both. X squared times x is x to the third. X squared times negative 4 is minus 4x squared. Then I multiply the second one. Negative 2 gets multiplied by both. Negative 2x squared plus 8x. And then I multiply out the last one. Negative 3 gets multiplied by both. Negative 3x plus 12. Then we combine our like terms. So I get x to the third minus 6x squared plus 5x plus 12 equals f of x. So this is the function that would have the zeros they originally gave you at the beginning. Questions so far? All right, then they just get a little bit more complicated. Like we get square roots in here. Eventually we'll get our complex numbers, like after we get into the i's. If you remember i's, we're going to go there after, like in 2-4. And then we bring those back in. But for right now, it's either going to be a whole number. It could be a fraction too, or it's going to involve square roots. So same process, find the polynomial function that has the given zeros. I still have to do x minus, and this is where you got to be careful because I'm going to put it in parentheses the first time. You don't always have to do it. But I have to remember that negative gets applied to both those terms. So then it's x minus 3 minus root 2. So now that x, or the negative, changes both signs. I'd get x minus 3 minus square root 2 and x minus 3 plus square root 2. So the negative is going to change both signs on your terms. And then first term times all three things. So x times x is x squared. X times negative 3 is negative 3x. X times a positive root 2 is positive root 2x. Then I go to the second term. Negative 3 gets multiplied times all three. So negative 3x, positive 9, negative 3 root 2. And then the last one, negative root 2x, positive 3 root 2, negative root 2 times root 2, which is negative 2. All right, so again, if you get opposites, then things are going to cancel. You got to look for them. And it's the things with the roots. So positive root 2x and negative root 2x are going to cancel out. Negative 3 root 2 and positive 3 root 2 are going to cancel out. And then we combine our like terms. There's only one x squared. There's 2 x to the first, so it's minus 6x. And then positive 9 and negative 2, positive 7. And then my last step, set it equal to f of x because this is a function. And there's the equation that would have given me those zeros. Still good? Last one kind of puts the last 2 days together. It says find the polynomial function with the leading coefficient 1. That means once I multiply this all the way out, the very first x should have 1, right? Or not have a number there. That has the given zeros, multiplicities, and degree. So it tells you that a 0 is 3 with a multiplicity of 1. That means I get 1x minus 3. Then it tells you you have a 0 that's negative 2 with a multiplicity of 2. That means I have x minus a negative, which would be x plus 2 twice. And then it tells you that the degree is 3. So when I multiply this all out at the end, I should end up with an x to the third. So use your like shortcuts on things like this. If you've got a perfect square, meaning 2 of the same factors, like x plus 2 and x plus 2, then the shortcut is square the first, square the last, double the product. If you wanted to use the shortcut, it will save you time. And then just make sure you multiply it times x minus 3. So x times x squared, x times 4x, x times 4, negative 3 times x squared, negative 3 times positive 4x, and negative 3 times 4. And then combine your like terms. X to the third. There are 2x squareds, positive 4 and negative 3, so positive x squared. There are 2x to the first, positive 4x and negative 12x, so negative 8x, and one constant, minus 12, equals f of x. And then use your checks. Is this a degree of 3? Yes. Does it have a leading coefficient of 1? Also, yes. Good so far? Good, you're done. Okay? So this is one of those days you could actually knock out that homework before you leave if you're smart. Okay? Because the homework's not that long either.